Hello and welcome to the video lecture associated with query optimization in a distributed database environment. So we've got multiple sites out there that have their own data. Maybe they're horizontally partitioned, maybe they're vertically partitioned. So if they're vertically partitioned, we're talking about multi-site joins. And the distributed database management system must decide where to access the data and how to proceed with the join. So it's a three-step process. The query is decomposed into separate queries that can be initiated against the various sites. The data is then localized, and then the query is globally optimized. So it's kind of it's a complicated process. I'm gonna show you an example in just a second. And then we have a semi-join operation where only the joining attribute of the query is sent from one site to the other rather than all the selected attributes. So let's take a look at an example. So here are some query processing strategies that might happen. So if we move the part relation, all right, and again they speak about it as a relation, in this case it's really a table, to Detroit, and process the whole query at the Detroit computer, that requires 18.7 minutes. Absolutely, completely intolerable. And you know that requires the moving of that entire part relation to Detroit in order to process the query on the Detroit computer. So it's almost 20 minutes, so ridiculous. If we want to move the supplier and the shipment relations to Chicago and then process the whole query at the Chicago computer, that could take 28 hours. We're not doing that, suffice to say. Or we can join the supplier and the shipment at the Detroit computer, project these down to only tuples for the Cleveland suppliers, right? So when we're talking about projection, remember selection and projection. So we've got a where clause that's going to project these down to only tuples for Cleveland suppliers. And then for each of these, check at the Chicago compute to determine if there's associated part is red. That's going to take us 2.3 days. All right, so that's not happening. So, but another option would be to project the part at the Chicago computer down to just the red items. Then for each of those, check at the Detroit computer to see if there is some shipment involving that part at the Cleveland supplier. With a Cleveland supplier, that takes 20 seconds, so that's pretty quick. If we join the supplier and the shipment at the Detroit computer and then project just the supplier number and the part number for one of the Cleveland suppliers and then move this qualified projection to Chicago for matching with the red parts, that's going to take 16.7 minutes. So you can see every time that this starts with a join, we're talking the longest amount of time. And then the fastest way is select just the red parts at Chicago, move the results of that query to Detroit for matching with Cleveland suppliers. And that turns out to be the fastest method for getting this. So realize that depending on the query processing strategy that you use in a distributed database environment can have significant performance results. And that is the end of my video lecture on query optimization.